Today we will look at a way for programmers to define their own types. So if you don't find that there are enough types available within the C++ language, then hey, guess what? You can make your own types. So this falls under the category of what we call user-defined types. So we're going to look at two in this video. One is going to be the Typedef, and the other one is going to be the enumeration. So let's get started with that. So in this tiny program, which is really not much more than just a template, I have some variables declared: a double high temp, which is an array of 7, and a double low temp, an array of 7, and just the integer k that we'll use as an index coming up. Now, let's begin by looking at what a type definition is. So I'm going to put a line of code in here, and this illustrates the syntax for the typedef statement. So to use this, you have the keyword typedef that's over here on the left. Following that, you've got an existing type. This can be any of the current types that you have in C++. Then after that type, you specify another name, and I'm going to use real here. So what this is doing is this is creating an alias real for the type float. So this means now that we can use either float to declare a variable, or we can use real to declare a variable. So real then becomes an alias for the type float. So I just put the comment there. Real is an alias for float. All right, so now let's declare some variables. So let's put this line in. This is using the C++ type float for average temperature, and we'll set that equal to 0. But we can also use real, and we can declare variables with that. So we can have another line. Now I'm using real to declare max temp and set that to 0, min temp, set it equal to 0. So this is exactly the same thing as if I had declared max temp to be a float and min temp to be a float. So you can make up different names for the default C++ types if you want to. And in this case, I'm just making up this this type called real. Now remember that this is a type, okay? Real is a type. It is not a variable. You can use that to declare variables as I've shown here. So if you didn't like the word float for real numbers, then you can do the typedef, and now you can declare them using real. Those are real numbers, and that kind of makes sense. Okay, well, if you can do that, that means you can pick any name that you want to be the various types. So we could call float Charlie if we wanted to. We could have a typedef for double and make that Sam. But that starts to be kind of ridiculous. So we don't really want to do that. And one big reason we don't want to do that is because in the future, if somebody else wants to read this code, they're not going to know what Charlie is in terms of a float. If we did typedef float Charlie, then we'd use Charlie to declare variables down here. Then that's going to be really confusing to people that read this code in the future. It might even be confusing to yourself if you don't remember that you did that. But this is to show you the syntax, okay? So this is a way you can do it. Now, let's look at another application of typedef, and I'm going to do an array this time. So let's declare another typedef, and we'll paste it in there. So again, okay, typedef, you lead off with that on the left. You pick an existing type next, then you give it a name of your choice. So in this instance, I'm going to declare another type, an alias for double, called temperatures, and not only that, it's going to be an alias for an array of 7 doubles. So you can include the square brackets here and the dimensions of an array if you want to. Now, in order to use that typedef, then I'm going to declare a couple of other arrays. So let me just put the line of code here for that. So I'm going to use temperatures. Okay, so temperatures is the alias that I have for double, and you can see now it's got that lower. It's not a dark blue; it's a kind of a greenish blue. So indicating it's a kind of a reserved word now. And I've declared variables high and variables low. All right, now that's exactly the same thing as if I had declared high and low to be an array of 7 doubles. Okay, so up here I've got a regular double for high temp and a regular double for low temp where I have the square brackets and a 7. Well, here's an alternate way you can do it. You can just put in a typedef and you can name it whatever you want, and you can make any dimension for the array here that you want. All right, now you can decide how useful that's going to be to you, but the language allows you to do it. So now I can use high and low, and I know that there are going to be arrays of 7 double values each. And if I wanted to, I can just go ahead and I can initialize them here when I declare them. So now I've just added the declaration and added on the initialization to set these values of the array to all zeros. All right, so this again, syntactically, that is how you do it. The typedef is really something that comes into play when we're talking about structures and when we're talking about objects. So they may not appear to be very useful here, but later when we start talking about those things, structures and objects, then they'll have a better application at that point. But anyway, it's part of the language, and here is how you can use them. I'm going to use these variables as we go a little bit further in the program. But for now, I'm just going to leave it at this as far as typedef is concerned. Okay, so remember you can use typedef, pick an existing type, and then you can redefine it and use an alias, picking some variable or name as your choice. It's not a variable, it's just a name, identifier. Now, let's move on and let's look at what we call enumerated types. I'm going to put my enumerated type up here in the global area. Normally that's where you want to put these enumerated types because you want them to be available to all functions in your program. If you put the enumerated type inside the main program, then by the scope rules, then it only is available to the main program. So we want to make it more universal than that. So normally you're always going to want to put your enumerated types up here. Now let's look at the syntax for that. So for an enumerated type, then you start out with the keyword enum, E-N-U-M, for enumerated. So you see that turns blue. Okay, now there's no equal sign involved here. You then have to specify everything that you want this type to be inside a set of the double curly braces. Now I'm going to make an enumerated type for weekdays. I do have to give it a name, so let's call this weekdays. And here is the name. So that's the identifier. So enum is the C++ reserved word indicating that we have an enumerated type. The name of the type is weekdays, and the values that type can take on are shown here inside the curly braces. Now I'm just going to go ahead and get my definition for the weekdays, and I'm going to copy it and paste it so I don't take a lot of time typing. So I'm just going to put it right here. Now, one thing that may jump out at you at first is that these are all uppercase. All right, so by convention, that is normally what is done. It is not required, but because these are special things, then we usually indicate the enumerated types in uppercase letters. So here I have the weekdays, and inside the parentheses, the curly braces, I spell out the days of the week, Sunday, Monday, all the way through Saturday, and I separate them by commas. Now, notice that these are, they don't have double quotes around them. Okay, so these are not strings. Okay, they are not even variables. They are what we call identifiers. Okay, so everything that weekdays, the type weekdays, everything that weekdays can become is listed through here. Okay, so those 7 words, those are the only possible values that weekdays can contain. If I tried to set weekdays to January, then I would get an error because January is not part of this list. So with the enumerated types, programmers spell out exactly what the extent is of the enumerated type itself and the, what the variables or the identifiers are called. All right, so syntactically, that's how you make one. And notice we do have a semicolon at the end over here. So that's syntactically how you make a type. And let me emphasize that this is not a variable, this is a type. So we're talking about user-defined types in this video, so we're creating new types. We use the Typedef to make a new type, which is called real, that was an alias. Now we're making another type, we'll name it whatever we want, and then we have a set of things that it can become. So you can see that these enumerated types can be really a vast different, there's a lot of different possibilities for them. So you could have the months, for example, January through December in here. You could have all sorts of things. You could have the list of the states. You could have within a state the list of the counties. If you're interested in sports, you might have a list of football teams in here. It could be anything that you want it to be. Well, what good are they? How are we going to use these things? How would we? Well, let's continue through the program and let's see how we can use those things. Well, if we have something that is going to be a type, then we need to use that to declare a variable. So let's declare a variable of type weekdays. Okay, so notice weekdays is the type, the variable is today. So don't confuse those things. Weekdays is the type, the variable is afterwards, just like we'd have float mass or integer age, things like that. This is a type that we just declared, weekdays. But to use that type, we have to declare a variable that belongs to that type. Okay, so today is a variable that can be of type weekdays. What that means now is that the only values that today can take on are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. Those are the only possible things that we can set the variable today to be. All right, now let's go ahead and let's see if we can set a value. Let's give today a value. So we're going to do today is equal to, and let's just make it equal to Sunday and semicolon. Okay, now that's perfectly legal. Okay, Sunday is one of the things in our enumerated type up here. Okay, so we are allowed to do that. So we can set today equal to Sunday. All right, now if we try to set it to something else, you could see we would get an error. For example, if I wanted to abbreviate Sunday and just put sun here, then sun is undefined. Okay, it isn't part of our enumerated type. Now we could add those in if you wanted to. We could have the full day and we could have the abbreviations, and then we'd have 14 things in our enumerated type. But we didn't do that. Okay, so sun isn't legal. We get a red line under it. It's undefined. Okay, so we have to use something that is part of the enumerated type. So let's put Sunday back in there. Now, let's try to print this out. So I'm going to just put a cout statement here after we set today equal to Sunday. Let's print it out. Cout. Today is, and we'll print out the variable today. And what do you think we will get when we do that? Well, there's no better way to find out than to compile the program and run it to see what we get. So let's bring over our output, and look, today is 0. Wow, okay. Didn't expect that. I was sort of hoping to see Sunday show up there, but today is 0, which isn't very useful, is it? What is this? What's going on here? Well, let's go ahead and stop the program and go back and investigate this a little bit further. Now, I'm going to go back up to where we set all of the values for weekdays in our enumerated type, and if I hover over them, then in Visual Studio this will pop up, and it tells me Sunday is 0. Okay, Monday, if I hover over that, okay, it's 1. Monday is 1. And if I continue to go down the list, then the values just go from 0, 1, 2, 3, and so on. So Tuesday is 2, and if I go all the way to Saturday, then its value is 6. So these are not strings. Okay, these things, Sunday, Monday, Tuesday, those identifiers, those are not strings. Those are just identifiers that represent what we call ordinal values. So when you create an enumerated type, and this is important, when you create an enumerated type, you give it a name, then whatever you put in this list is really going to be an alias for an index. It's an alias for an index. So Sunday is just an alias for the integer value 0. Okay, Monday will be an alias for the number 1. Okay, Saturday is an alias for the number 6. So when I tried to print out today, I set today equal to Sunday. Well, Sunday is just the ordinal value 0. Therefore, when I printed out, I did print out the value 0. So with enumerated types, they aren't really good in terms of if you're trying to print out the names of things. Like if we wanted the names of the days of the week, then we would probably use an array of strings. We'd set up a string array, call it weekdays, and then we'd initialize it to the actual strings, Sunday, Monday, Tuesday, and so on. It turns out that these enumerated types really are not intended for input and output. What they're really intended for is to use something that we humans recognize instead of numbers for indices. So now we can use the word Sunday, or we can use Wednesday to represent an index into an array. And that's where the real value of these things come into play. So let's do that. First of all, though, let's look at one other thing just to kind of emphasize that it really isn't, enumerated types are really not good for input and output. Let's try to read in something. So let's put a cout statement here. Okay, enter another day of the week, and I've got a comment. Let's take the comment off, and let me try to read in today. Well, if today was an ordinary variable, then we could do that. Okay, if today was an integer or a float or a string, then this would be just fine. But what this is essentially saying is today contains Sunday, but Sunday is actually the number 0. So this gives me an error because this is exactly the same thing as if I had put the digit 0 there. And that doesn't make any sense. Okay, you can't read in a constant like that. It has to be a variable. All right, so we can't read in like Sunday. You know, that's the same kind of thing here. If I put Sunday there, then that doesn't work either. So these are not intended to be input and output devices. So I cannot do that. So let's go back and I'll just go ahead and restore this to the example that I started with so that I'll not lose it. So let's put that back in here. So this is not allowed. That's the same thing as saying CN0. Okay, so I can set the variable today to be any of those enumerated types, but it's not fit for input and output. It just represents a number. Right? So let's comment this back out because our program will not run if I try to do that. Now, let's see how we can use those enumerated types. We have declared our high and our low up here with temperatures. So I'm just going to make put a couple of lines here. And I have the variable high. Okay, so I declared that using my enumerated type temperatures. But that's going to be an array of 7 things. You can see it right there. Okay, 7 items. So I am going to set the 0 index of a high to 89.5, and I'm going to set the index Sunday of low to 71.4. So I'm going to use these two arrays, okay, high and low. Okay, now remember, those are essentially the same things if I had declared them to be a type double up here with the square brackets. All right, so this one's called high temp, so don't get it confused. That's different altogether. But by using the high and low here that I've declared using the Typedef temperatures, then I can treat that as an array of 7. Okay, so that works out just fine. Now, I have set the high for Sunday to be 89.5 and the low to be 71.4. Now I can print those back out, and just to show you how we can do that, and this is pretty simple, let's just print those values back out again. So let's put the cout statement in. The high temperature for Sunday is, and we'll print out high Sunday, and the low is low Sunday. So I'm using the enumerated types as indices into these arrays. Now, I could compile them on the program, but it's not going to be a surprise. This is exactly, it will be what you think it is. It'll print out 89.5 and 71.4. I probably should do a fixed in a set precision up there before I do that. But at any rate, that's what will happen. Now, let's look at printing out some values. Actually, I'm going to input the values here. Let's load up our array of highs and low temperatures with a for loop. So I'll just drop that in here. Okay, Control V, we'll paste that in. And here's the for loop. Now, here's where perhaps the enumerated types really start to show some usefulness. I want to go from Sunday all the way through Saturday. And I don't have to use numbers here. I can use these enumerated identifiers. So what that really is saying is for k equals 0, k less than or equal to 6, then we'll go through the loop and change k with k++. Inside the loop, I still have to use the index k here. Okay, k's changing. K starts with 0 and it goes up to 6. So I can't use Sunday in here because Sunday would not ever change. Right? I'd have to add 1 to Sunday, and I can't do that. All right, so we have our loop where we have our index as being variable, but we now have a indicator, an identifier that's easily understandable as the first day of the week. And this one is easily understandable as the last day of the week. So we can pretty well understand if we said, hey, we want 0 to represent Sunday, we want 6 to represent Saturday. That's easy for us to keep up with. But what if we had a big array of like 50 states and we wanted to do something with the state of Nevada? All right, well, we need to go look up a table or have a table to say, well, what index is Nevada? If I have an enumerated type that has all the states, I don't have to remember that index. And I'll show that in an example coming up. All right, but for now, let's just go ahead and run the program, and let's use our enumerated types as indices into these arrays. So let's compile the program and run it. Let's bring our output window over here. And here you see the output that we have already. All right, so we had today as 0. That's already up further up there. And we're going to enter, well, let's see, enter another day of the week. Well, I commented that out right there. Okay, so we can't enter a day of the week. We're not allowed to do that. Okay, so what the output then is telling us from these two lines is that the high temperature is 89.5, the low temperature is 71.4. Okay, so that came from these two lines, and you can see we're using the identifier Sunday to represent index 0. Now, we're going to go through this loop, and you can see it is prompting me to type in the high and low temperatures. Okay, so I'm going to go through this, and I'm just going to type in those values. And then nothing else is going to happen because there's nothing else in the program. So let's see, the high first, I'm just going to make that easy. So I'll put a 90 and a 70, and then I'll keep going, 91 and 71, till we get through the rest of the week. 92, 72. Gets a little hotter each day, doesn't it? 93 and 73. Okay, day 5, 94, 74, and let's see, day 6 is 95 and 75. Okay, and then finally the last day, 96 and 76. So this goes through the loop, and we can type in these temperatures, but we don't do anything with them just yet. So the purpose of that little exercise was to show you that you can use these enumerated types within a for loop, and it makes it more readable. So we know we're going from Sunday to Saturday, and instead of just going 0 to 6. So it makes your program more readable to be able to do that. Now that I've loaded up the arrays with high and low temperatures, let's print them back out. So I'm going to have a table. I'm going to print out, and I've got the cout statement here. Okay, set width to 10. I'm just going to print out these column headings. Here's the day, and here's the high, and here's the low. Then I'm going to go through the loop. Okay, for k goes Sunday to Saturday again. And then I've got this for loop. Now, what I'd like to do is to print out the actual name of the day, instead of the value k, which would go 0 through 6. So, how can I do that? Well, I'm getting a little ahead there. Let's print these out, first of all, just looking at the index k. Now I do want to get to the point where I print out the name of the day instead of the index, but to begin with, let's just do this. So we'll have the same for loop that we had up above, and we'll just print out the values. Okay, so when I run the program and I bring it over, then here's the output. And I did go ahead and type in the values first, so you didn't have to waste time watching me type that in again. So here's the output then from this bottom loop. So the value for k starts with 0 for Sunday. It goes up to 6. We go through this loop, and we just print out day 0 through 6. We get the high, and we get the low. All right, now that's okay, but again, these digits 0 through 6, those aren't real meaningful. What days are we talking about? So it'd be better if we could actually have the name printed out there. All right, so let's go do that. So to do this, what I want to do is to somehow associate this index k with the name Sunday, and for index 1, Monday, and on down the line. I could have a bunch of if statements for that, and I'm telling you here something that is different than I mentioned up above, that these things are not good for input and output. And I think you can see that by we're printing out the numbers 0 here instead of the days, and we couldn't print out Sunday anyway. We can't do that. So I'm going to do a little modification to this so I really can print out Sunday, Monday, Tuesday as names. So to do that, I could have a bunch of if statements. Okay, if k equals 0, then print out the string Sunday. Else if k is equal to 1, then you print out the word Monday. So we could do if statements, but there's also a C++ structure we can use that would be better. It's called a switch statement, and you should know what that is. But I'll explain it briefly here. With the switch statement, we can combine a bunch of if statements together. So to build a switch statement, you start with the reserved word switch. Then you have a set of parentheses. Then inside the parentheses, you have to have something that's an ordinal type. Certainly an integer is an ordinal type. And we could have letters if we wanted to. We could use a character type in here, and so on. But we're just using an integer this time. We're using this k value. So within this switch statement, we have to specify clauses or cases for all possibilities that k can become. And that's what we have here. All right, so outside the switch to begin with, we have the reserved word, and then we have a parentheses, and we have some ordinal value inside there. Then for each value that k can become, we have to have a corresponding case statement. So it's written like this. We have case, and one thing that k can be is Sunday. Right? So we start out k is equal to Sunday. That's fine, which really means k is equal to 0. So this is the same thing as if we said case 0 here. And if that is true, we have this out statement that prints the string Sunday. So if k is 0, we execute this cout statement and we print Sunday. Now if you're not familiar with the switch statement, you have to put a break after each one of your case statements so that you'll not execute further case statements that go after this. Okay, so you might want to research that if you don't remember it. Now this just takes care of Sunday. So I need to put in the cases for the rest of the week. So let me just drop those in here. And I've got a case for Monday. I've got a case for Tuesday. And notice there's a colon right afterwards, all the way through Saturday. So one of these 7 will be true, and I will go ahead and print out the corresponding day for whatever that is. And in this case, k is going 0 up to 6. So each time we go through the loop, we're going to execute a different part of the switch statement. So for 0, we'll do that one. When it's 1, when k is 1, we'll do the Monday one. When k is 2, we'll do this one all the way down to when it's 6. We'll do this one down here. We'll not do any of the others, so we'll only do one of those. Okay, so that's why you need the break. So one more time on this break statement. If we didn't have the break in here and we did Sunday, then we would immediately go ahead and do Monday. And if we didn't have the break there, we'd immediately go to Tuesday. All right, so if you only want to do one of these, then be sure to put a break after each of the case parts of the switch statement. Now, we have everything we need for the 7 days of the week, and then we'll close our switch statement with the curly brace at the bottom. All right, now what's this going to do? The first thing it's going to do is it's going to print out the day of the week as its name, okay, Sunday in this case instead of 0. But I haven't printed out the high or the low yet. So when I do these cout statements, notice there's no end line. So when I print out Monday, there's no end line, Tuesday, and so on. So after I've printed out the name, which goes in column 1, then I want to print out the high and the low. So that comes in next. So let's put that down here. So we'll drop that in. And we will print out the high here with the cout, and we'll print out the low. And we'll just use our indices brackets K here. So when we print out the name, we have the cout, we have the set width of 10 up there. There's no end line. So then I'll continue here with the set width of 6 and the high and the low. So that will match up with this header that we have up here at the top. Wow, okay, that's a lot of work to print out just the names of the days, isn't it? But let's compile the program, and now let's run it. Now let's look at the output. So I'll bring this over, and again, I have already typed in the highs and the lows to fill up the array, so you didn't waste time watching me do that. But now we have a table that is more readable. So on Sunday, the high was 80, the low was 60, and we just go down the week, and you can see the output that we get for all those days. All right, so then we have a nicer table in that case. But we really kind of had to work our way around using that enumerated type in order to get this. All right, now let's move on, and let's look at another example. So this looks okay. I mean, we can tell where we're starting and where we're ending because of these names, these identifiers. We start at Sunday, and we go to Saturday. And we didn't have to do that. Okay? We didn't really have to do that. We could have started, and in fact, it's probably a good idea to show you this. Let's use this very same example, but let's limit the days of the week. Let's suppose we're not interested in the weekend. Okay, so let's change that, and let's make it Monday. Okay, so let's suppose we are looking ahead at our forecast, and we're interested in the work week. So we want to go Monday through Friday this time. So this then is very readable. I've just changed from Sunday to Saturday, and I'm going from Monday up to Friday. So it's very easy to do this, and it's very readable when we do that. So we don't have to remember that 1 is Monday and 6 is, 5 is Friday. We don't have to remember those indices. And now this will also print out the table Monday through Friday. Okay, so let me show that to you. And now let's look at the output that we get. So again, I've typed in the temperature, so we didn't have to watch that. But our table now comes out just showing the weekdays, Monday, Tuesday, Wednesday, Thursday, and Friday. So we changed our for loop just to look at the work days instead of the weekends. So that works nicely. And it was easy to do. It was really easy just to change this from Sunday to Monday and Saturday to Friday. All right. Now I've got one more example I want to show you as an illustration of how to use enumerated types, and I want to bring in a function in order to do that. We know that functions go below the main program, and I've put that in down here. Let's take that out, and no, that's okay. I'm good to go here. I did go ahead and paste it in. Normally I would let you watch it paste in, but I'm not this time. I just did a paste. So here's the end of the main program, and here's our function. So I'm going to use a function that's going to print out the school menu. So remember your school menus. So this is going to have a parameter called day, and the type of that parameter is going to be weekdays. So this is our formal parameter called day, and it's of type weekdays, which means that the only values it can take on will be Monday, Sunday through Saturday. All the things that are in the enumerated type weekdays. Inside this function, we're going to print out the lunchroom menu for that day. So I'm using this switch statement again, but notice We just go Monday, Tuesday, Wednesday, Thursday, and Friday because we don't have school on weekends. And we actually print that out down here, and I'll show that shortly. So we'll come into this function, we'll send it the enumerated type, or the variable can be something within that enumerated type, and we'll use that as the key here for the switch statement. And it will be Monday, Tuesday, Wednesday, Thursday, or Friday. Depending upon what day it is, we will print out the school menu. So this is just a bunch of cout statements. Okay, so on a Monday, the menu was chicken fingers, green beans, carrot sticks, and oatmeal cookie and milk. Pretty nice, right? So then we'll have to break right here because we don't want to see the menus for the other days. So with the switch statement, we need to put the break in there. But notice after you have the colon in the case clause of your switch statement, you can have a big block of code here. It can be as complex and as long as you need it to be. All right, now at the bottom of this, I added a default. So with the switch statement, you can do this. You can put in a default with a colon, and this is the same thing as an else statement when you're using the if statement. So it's a catch-all. If none of the cases up above happen to be true, then the default will kick in, and since we are only allowing weekdays, then we would print out an error message. Okay, so if we happen to input Sunday by mistake, then this default would kick in and we print out error, no school on Saturday or Sunday. Then we have the end switch, then we have just an ordinary return because it's a type void. So the only thing this function does is to print out our school menu. All right, so now we need to make our prototype. So I will just copy, scroll to the top and put the prototype up here. And let's put it right there above main. And we have the semicolon afterwards. Okay, now it's important that we actually put this after the definition. Okay, so if you're going to use weekdays, it has to be declared before you use it. So if I happen to put this prototype up above, then let's see if I take it out here, I think I would get an error message there. Okay, it looks like I'm not, but at any rate, it's better if you go ahead and declare your type before you use it. And so that might be something Visual Studio lets me do that most compilers will not. So I'm going to put it back down there. Anyway, here we go. So we have now the enumerated type, and then we're using it as a type declaration for day within our function. Now, let's call our function and let's find out what's on the menu for today. So let's put this at the bottom of the program. So I'll paste that in here. So let's prompt, okay, enter the day of the week to get the lunch menu. And it says CN school day. All right, well, okay, I didn't declare school day. It's undefined. How would you declare it? What would the variable school day need to be? You know, what type would it need to be? All right, well, you know that what we're doing here is we want to send in the day of the week. So what do you make it? Let's go back up let's go to the top of the program. Let's declare it. So I'll paste this in. Okay, school day, enumerated type for weekdays, right? Same type as weekdays. Is that what we want? Will that work? Well, we're really tempted to do that. Really tempted. But when we try to read it in, what are we going to get? Can we read it in? Well, no, we can't. Look, red line. We can't read that in. Okay, school day has to be something of the enumerated type weekdays. And you know we can't read those in. We just proved that earlier when we tried to do a CN up there with today. So we can't do that. Once again, it points out enumerated types are really lousy for input and output. So we can't make school day a type weekdays, but we can make it an integer. So that's what we have to do. Now, that's fine. We can read that in. And we can do that right here. Okay, enter the day of the week to get the lunch menu. All right, now, since we're doing input and output, then let's put a note here that we need to enter a value 0 through 6 in order to get the correct day. All right, so that's kind of bad, really. You know, If you have this kind of interchange with your user and you tell them enter 0 through 6, it's just not as clear as entering the day of the week. But we can't do that. We can declare the names of the week to the days of the week to be a string type. Then we can do it, which would ultimately be the best way to go. But anyway, this lesson's about enumerated types. So how do we get around it? Well, okay, we're going to type in, and I'll take this off for just a second. Okay, I'm going to read in school day as an integer, 0 through 6. If I try to pass it to the function, though, I've got a type mismatch. Menu, I'm trying to call the school menu. If I look at the function menu, notice that the type of the variable is weekdays. It's a type mismatch. All right, so I can't do that. But what I can do is to use our typecasting, or our what we call our coercion operator, to change this integer type to a weekdays type. So this is starting to look a little strange, I realize. So let's put that back in. So it's kind of weird, but we have to actually change this type from an integer back to a type weekdays. And the reason we have to do that is because of the way we declared the function argument here. Now it works though. All right, so we can input an integer for the day of the week, and then we can call our function to print out the menu for that day. So we had to do a little extra effort to make that work, but eventually it does work. So now let's run the program and look at this final example. Here's the output window. So I've run the program all the way down here. There's some weird temperatures there. Anyway, I've run this all the way down to the bottom so we can enter the day of the week to get the lunch menu. All right, so we know if we look at our switch statement that Sunday and Saturday are out, we get the error message. So let's just put in the value number 1 to represent Monday. So we'll put that in, and I hit enter, and then look, we get our menu for Monday. So we get the chicken fingers and all the good stuff with milk, and that's what we get from this output statement here in the switch statement within the function. The advantage, as I'm closing up this video, is that you can name your indices. So when we are looking at an array of things, instead of trying to remember the indices, you can give them a name, and that makes it easier for programmers to remember those indices. And I've got another video coming up which is going to illustrate that further. But that's it for this video, and remember, we talked about the Typedef in here, and we talked about the enumerated type up there, and I only did the one enumerated type. So in the upcoming video, we'll look at some different examples of enumerated types, but for now, we will stop.